Alright, when it comes to division of two complex numbers, let's say we've got z1 and it's divided by another complex number z2, there's two approaches we can take to finding the quotient. The first approach is to multiply z1 by the inverse of z2. So this is a perfectly valid way of evaluating the quotient, and let's do an example of that. So in example 1, I have z1 is equal to 1 plus I, and z2 is equal to 2 plus 3i. And the first thing I would do is to evaluate the inverse of z2. So z2 inverse is 2 divided by 2 squared plus 3 squared minus 3 divided by 2 squared plus 3 squared I. And if you're wondering how this comes about, please refer to the previous video on the multiplicative inverse of complex numbers, and I'll leave a link in the description below. And this evaluates to 2 divided by, so 2 squared is 4 and 3 squared is 9, so that's 4 plus 9 minus 3 on 4 plus 9i. And of course that simplifies further to 2 on 13 minus 3 on 13i. Now to evaluate the quotient, I can then find z1 by z2's inverse is equal to 1 plus I times 2 on 13 minus 2 on 3 on 13i, and then distribute this out to find the quotient. So we have 1 times 2 on 13 minus or plus 1 times negative 3 on 13i plus I times 2 on 13, and then plus I times negative 3 on 13i. And this then simplifies to 2 on 13 plus 2 on 13 minus 3 on 13i, and then plus negative 3 on 13i squared. And I squared is of course equal to negative 1, so this further simplifies to 2 on 13 plus 3 on 13 as the real component, and then the imaginary component is 2 on 13 minus 3 on 13i. And of course then this further simplifies to 5 on 13 minus 1 on 13i. Okay, the second approach to evaluating a quotient is to multiply the quotient by 1. Alright, and we can express 1 as the complex conjugate of the divisor divided by the complex conjugate of the divisor. So we're multiplying the top and bottom by the complex conjugate of z2. Okay, so if z2 is equal to some complex number a plus bi, then z2 bar the complex conjugate is equal to a minus bi. Okay, so in our second example, 2 times root 5 plus I divided by root 5 minus I. So in multiplying the top and bottom by the conjugate of the denominator or the divisor, I timed by root 5 plus I on the top, and then times root 5 plus I on the bottom. And then it's a simple matter of distributing this out. So this equals 2 root 5 times root 5 plus 2 root 5 I, and then plus I times root 5 plus I times I. That's the top. And then this is divided by, and then distribute out the bottom. This simply evaluates to root 5 squared minus I squared. And simplifying the top, I get 2 times 5, 2 root 5 plus root 5 I plus I squared all over. So root 5 squared is 5 minus I squared is negative 1, so it effectively becomes plus 1. And simplifying further, I get 10. And of course, I squared is equal to negative 1, so it really is 9. 2 root 5 plus root 5 is equal to 3 root 5 I all over 6. So the final result is 9 over 6 as the real component, plus 3 on 5 on 6, so 3 root 5 on 6 as the imaginary component. And I can simplify further to 3 on 2 plus root 5 on 2 I. So I hope these two videos have helped you better understand how to go about dividing two complex numbers. If you found this video useful, please give me a thumbs up, and as always, please feel welcome to ask me any math question by commenting below. Best of luck with your math studies, and I shall see you on the next video.